Hello, group. Welcome to the October meeting. So there are 1, 2, 3, 4, 5 of us here in person, and how many on Zoom? I'm not.
9. Well, we got to subtract a couple.
Well, 8.
Yeah.
8 because the training room was one of them.
Okay. Does anybody need help with any troubleshooting? Resounding silence. Okay. Did anyone participate in radio activities for the Eclipse light? And how did that go?
Well, I understand. I'm sorry. Who wants to go first here?
Mac, and go ahead, Mac.
I did FT8 during the Eclipse, and at least for me on my station, I didn't make one contact. I don't know what it says. Other people have, but I did. My PSK reporter said they were seeing me and everything else, but no one ever got back.
Cool. Paul.
Yeah, I was transmitting. I was transmitting FST 4W -120. If you're not familiar, it's similar to Whisper, but it's the decoder's got more information coming out of it. Strictly beacons. I was transmitting from 2 locations, Friday Harbor, Washington, and where I am right now, Occidental, California. I was just transmitting. I was using the thing that we designed called the Beacon Blaster 6. I'll talk a little bit about that. So I was putting out signals simultaneously on 6 different bands, 80, 40, 30, 20, 15, and 10 meters. And it was, we got receivers all around the world, and I got lots of reception. And the guys that are running the Whisper Demon system, which is a bunch of receivers basically, got some really good data regarding propagation variations before, during, and after the sunspot. I was not the only one, obviously, transmitting, so we've got all sorts of paths. Some stations directly underneath the Eclipse, others like mine, off to one side. But we've got a huge assortment of transmit receive locations, and the data is, being combed through right now, trying to come up with some nice summaries of it. So that was pretty gratifying.
Bud, any update on the Nexus DRX?
Well, yes. I got an email today. I've been sending emails back and forth between me and Craig, KM6LYW, that does the DigiPi project. And he has discovered that with the new Raspberry Pis that are coming out now, even though they may be a 3 or a 4 or even a 0, when you run Direwolf and our FePi sound card, or even with the Audio Injector Z sound card, but they're both I2C sound cards, that the CPU spikes up to 100%. And it's only on the new Raspberry Pis. If you've got an older Raspberry Pi, it doesn't do it. And this is something that's just been discovered. A second email that I got from him, and I'm trying to figure it out myself, he said that a simple solution to the problem was in your Direwolf config file to change, there's a setting in there called A channels, and typically we run it as A channels 1, which basically says that we have a mono, it's a mono audio. And by changing it to a channels 2, which indicates this is stereo, the CPU comes back down to normal speed. I mean, things are normal again. I'll try to get a hold of Steve Magnuson and see what the ramifications of that might be, because with our Nexus DRX, the fact that we can run 2 radios at the same time, each one is on a separate audio channel, left and right, that might have an effect on our ability to do that. I don't know how many people run 2 radios simultaneously. I used to do it all the time, and now I don't even seem to, I don't do it, but it would be concerning, and we'll see what we can find out. And so if you're running Direwolf, if you're running Packet on the Nexus, and you have a newer Raspberry Pi, take a look at that CPU usage and see if it's cranked up to 100%. And, we'll have to see what that's going to do to us. But that's it, Steve.
Okay. I just put a teaser note in here that the new Raspberry Pi Bookworm OS is got huge amounts of changes to the infrastructure, including the audio handling system. So there be dragons. So don't try it until Steve Magnuson blesses it, which I doubt is likely. We're probably just not going to tinker with it. Let's see. Oh, and let's see. I just had a note in here about the wiki, the digital groups wiki page, and I just threw a quick update in there, and in the announcement I asked people to take a look at it and see if they could think of anything that it needs. I didn't get any feedback. I didn't see anything posted to the list, so we'll call it good. There's a fair amount of info that's in there that's at least a year old, and I'm not sure if any of those remote nodes are even still up. So I haven't checked them a long time. Let's see. And if we breeze through everything and we've got time to kill at the end, I'll talk about my Meadow Day experiment with Starlink. And Bud, were you able to edit the video?
I'm sorry, Steve. I didn't realize you were going to want it tonight. I haven't gotten there yet. But
okay, but it's watchable. It just drags on. You know, Bud tightens it up something wonderfully when he edits. So, and then I have a 5-minute update on zero retries. Interesting. So, but I want to give the floor first to Paul to give him plenty of time to talk about his interesting stuff. So before we switch over to Paul, anything else that we need to talk about internal DG business? Going once, going twice. Okay, Paul, you're up.
Okay, I'm going to try to share a screen here. Let's make sure I remember how to do that. That would be this. Share, it's going to ask me.
There we go. Hey.
Oh, okay, good. All right, so can everybody read what that says?
Yep.
Okay, good. Turn Island Systems. Turn Island Systems is a company that Steve over there, Steve Roberts, and for RVE, and I started, I don't know, year and a half ago, maybe longer. Steve and I are we're sort of separated at birth, except we took vastly different paths after we were born. So, but we found ourselves, discovered each other some time ago on a sailing forum talking about electronics, and turned out he and I had both moved to the same island. So started doing some fun stuff together. One of the things, hate to admit it, still haven't finished it, is a drift buoy, something that would send a beacon and just float around in the ocean. Lots of people doing it. I thought, well, we could do one and it would be even better. But so in the process, ended up with a lot of interesting things. So here, okay, here's a picture. You see my cursor moving around on the screen there?
Yes, we do.
Okay, that's me. If you go to Wikipedia, type in Telecom Valley, you will find I am the poster child for Telecom Valley for some reason. Somebody found an old picture of me probing, I don't know, probably a T1 board or something. That was some time ago, but I've been involved in electronics ever since elementary school, really. And I retired some time ago, kind of early, for good reasons. And but now I still can't kick the habit, so still do this stuff. And Steve, you know, he does recumbent bicycle stuff, and he's still, as I say, still tech, maybe a little bit less nomad. But we're having a lot of fun doing this Turn Island system stuff. Let's see what's on. I don't have things prepared, but I did put pictures kind of in order to remind me what to talk about. One of the first things we did is in Turn Island, I wanted to study the frequency stability of my drift buoy, and my old Hewlett-Packard frequency counter with the Nixie tubes on it was crapping out. And looking at what I wanted to do with the frequency counter, I just couldn't see myself spending all the money for a fancy frequency counter. So I went and designed one of my own. It's a time interval counter, 10 megahertz reference clock, 100 megahertz PLL inside. Most of this stuff, it's really a little bit of analog front end stuff and a little microcontroller, which is essentially a also an Arduino style, but it's on the board. I put the chip on the board but sort of clone the design, and it's got an FPGA that does all the heavy lifting.
Where do you get your 10 megahertz source, Paul?
I've got two sources. One is there's a jack on the back to an SMA. That's an external 10 megahertz input. So that would nominally come from a GPS DO, GPS stabilized oscillator, or an OCXO or whatever. Internally, I've got a TCXO, just a fairly garden variety TCXO. It's adequate for most use, but if you want to be really precise and stable, then you feed an external clock into it. And I'll talk a little bit more about that pretty soon, I think. The other thing was I liked I don't know if you're familiar with the SI5351. It's kind of like the go-to synthesizer chip for so many radios and lots of other stuff. It's got two PLLs in it. It'll take an external reference. PLL typically runs between 500 to 900 megahertz, and then it's got fractional dividers. Don't get me started on fractional dividers because I love those things. I'll talk for hours about them. But it's got fractional dividers on the PLL phase lock feedback loop. Also, it has three outputs with their own fractional dividers. And so the chip will put out anywhere from, I don't know, it's like 8 kilohertz or something, all the way up to, over 100 megahertz with amazing frequency precision. I mean, it's got to be factors of rational numbers, but the way it's designed, you can get pretty amazing stuff. So I designed this clock box. I put an SI5351 in it, put the 10 megahertz reference on the back if I wanted it, internal OCXO, and then I had buffers for the outputs. So I'm trying not to talk too much here about it. But if there are questions, I'll go on and on. So in the process, there's a radio called the QDX, QRP Labs QDX. If you're not familiar with it, check it out. It's pretty amazing. And Hans, the guy that runs QRP Labs, even has a newer one that'll do sideband, I believe. I haven't played with it myself. But this is a digital transceiver. audio in. I won't go on and on about it, but it's really cool. You should check it out. So I was hanging out on the QRP Labs forum on the internet, discussing that transceiver. We were talking about frequency stability issues. For most modes, the QDX is just fine, but some of the, even Whisper, and then the slower digital modes, like the FST4W modes, the thing, it just has too much drift. So we're looking at ways to stabilize it. And I spent a lot of time on the internet with Hans. Again, Hans, the guy that owns QRP Labs, and really couldn't figure out a good way to stabilize the oscillator on the board. There are just too many thermal issues. So I designed an external clock adapter for that. Either a direct 25 megahertz input, or I have another board that's a clock multiplier, feed it 10 megahertz or 5 megahertz, and it multiplies it up to 25 megs, which is what the QDX needs internally. Turned out I had a 10 to 25 megahertz multiplier in an earlier version of my clock box. That's the one with the SI5351. So I was able to repurpose that design. And talking about this, these different modes, and turned out, I learned about FST4W and the ionospheric propagation research. And I've got links for that if you're curious. And I'd already turned the clock box into a Whisper beacon just because it was fun. So, and turned out they needed, for this research, they needed a multi-band transmitter. So I figured, hey, how hard could it possibly be to modify my design, turn it into a 6-channel beacon? Well, actually, the design was pretty easy, but the implementation is, well, we can go on. Here's the time interval counter internals. I got 4 input stages. The stuff in blue or light blue is what's inside the FPGA, and there's a little bit of partitioning here that's not quite right, but this just shows the essence of it. Cool thing that I added late in this, and wonderful thing about FPGAs, is I didn't have to even change the board layout. I had a numerically controlled oscillator and a digital mixer inside, and a digital filter. So now I can take an input signal, I can mix it down in frequency down to 10 hertz or 100 hertz or something, and get amazing effective precision quickly. Here I'm showing what my time interval counter is doing with FST4W QRP Labs transmitter. You'll notice this is the modulation, but you notice the drift starts transmitting, temperature, the frequency goes up a little bit, then it goes down and it slowly stabilizes. And 30, 21, 30. This is this is over half an hour from start to finish, roughly. Question?
Is the thermal drift a result of the transmitting and then heating up?
Yes. Yes,
Okay.
The output final stage, which is 4 TO92 FET transistors, they put out enough, they're only about, they're not much better than 50% efficient. It's a class D output because it's a broadband at that stage. And it puts out a fair amount of heat, which propagates across the circuit board and inside the cabinet, just air temperature, but I think it's mostly circuit board. And then that gets over to the, it's a good TCXO, but even a good TXO isn't good enough for this stability. It's a fraction of a hertz. It's drifting a couple hertz, but that's way more. You could not decode this signal. The drift has to be less than a symbol width or frequency shift. And here the drift is way more than that. So with my fancy time interval counter, I can get, basically I can get better than 100 microhertz, 1.1 millihertz frequency resolution of a 10 megahertz signal, sampling that signal, getting samples at 100 hertz rate. So that's, okay, you can buy other frequency counters that'll do this, but you got to spend good big bucks for them. So I was happy with that. And here you can measure, this is what you can do with that counter. Here I'm measuring, again, the QDX TCXO. This is I had the thing in a temperature chamber, a modified thing that they call a reptile incubator, but of course it's a thermoelectric cooler. I built a controller to control that thing, and then software to control the controller. So anyway, you can see the frequency drift as the temperature goes 10 degrees up to close to 50 degrees centigrade, drifts up and down again. But you notice it's got what's called retrace. In one direction, it's high, coming back down, going cold. I think that's one direction, it's high, the other direction, it's low. And then you go to small frequency variations, you get the same sort of thing. It's not a single line, which is something that many people, I did not initially know what was causing that. It's an effect called retrace. If you go to my wb6cxc.com blog, I think I have some presentations on this, so I won't. But anyway, so you can make really precise measurements, and it came in really handy in figuring out what was going on at the QDX. Here we go. So, okay, out of that, Turn Island Systems developed our clock reference interfaces. Here's one 25 megahertz input. It's really just input protection. Then it goes off and it feeds the oscillator buffer on the board, on the QDX board. Here's one with a little phase lock loop multiplier. It steals 3.3 volts from the QDX and puts out 25 megahertz. You can, if you have a 5 megahertz, yes, go ahead.
Just to be clear, these are mods to the QDX.
Yeah, I don't have a picture of it with me here now, but you can replace. I also came up with a replacement back panel for the QDX with a hole in it for this SMA jack, and I managed to shoehorn everything in. So the only mod you have to make to the QDX is you have to remove one capacitor off the board. It's a service mount capacitor, so you gotta, have some finesse when you're doing it, and then solder these wires. Fortunately, there were through holes that I could use for the power wires. This twisted pair here, the small one is the 25 megahertz clock. I'm able to feed those two wires through a through hole to get to the other side of the QDX board. Again, I've got a documentation on these clock interfaces on the Turn Island Systems website if anyone's interested in the details. I think I got a schematic on there and everything. Okay, so yeah, here's the clock box. I already talked about that. But that's just, it's something that I use myself. Haven't tried to sell it yet because I'm not happy with the kind of user interface software. I mean, that's the hard part, is getting the software. I can drive the thing, but I wouldn't want to inflict it on anyone else at the moment. So clock box to beacon blaster, more Turn Island System stuff. The beacon blaster, as I mentioned, is a 6-channel transmitter, and we kind of went back and forth on, well, what do we want this thing to look like? What are the requirements? What do we include inside the box? What do we put outside the box? And finally I decided that, okay, I've got two SI 5351s there. Had to learn, is that showing up? I'm curious, do you guys see a little notification that popped up on the screen there? No, good, okay. So the screen sharing knew what to do with that. And Steve, stop me if I'm droning on too long. Okay. So we talked to, I had to learn how to, these things use a I2C interface, and they only have one I2C address. So I had to come up with a multiplexing scheme. And you can buy I2C multiplexers, but to control those, you need to use I2C, and there's a whole protocol. And I needed to switch these things really quickly. So turns out an analog switch does a really good job of multiplexing. So I had to figure that out. Here's my external 10 megahertz reference, because you really want a stable clock when you're doing a FST4W. I stuck a GPS module on there, a little one of these, not an integrated circuit, but it's a little module that solders down to the board. So GPS antenna in, I put a GPS splitter, just a passive resistive splitter. So the antenna connects here. This powers the antenna, a little puck antenna with, that gets its power from this GPS chip. But then it splits and goes out of here. And typically what I do is I run that output, connect it to a GPS disciplined oscillator. That way we only need to use one antenna and we can share it. There are other ways to split a GPS antenna signal, but thought I'd throw it on the board. So I'm using a Bodnar, B-O-D-N-A-R GPS disciplined oscillator. It's a really good one. They're inexpensive, relatively inexpensive. And that's typically what we're using with this beacon blaster. So there's the little processor here, USB port for controlling it, and external power connections. And then these are the six outputs going through a buffer from the SI5351. And these are, every one of these is identical. You can transmit, you can put them all in the same frequency. You can pick any frequency in the ham bands or out of the ham bands if you want to do some special configuration. But typically, it'll be 80, 40, 30, 20, 15, and 10 meters, but it can be anything. So this is completely frequency agnostic inside here. These things then feed a 1-watt digital amplifier. And actually, I'm not inside the box. I'm not using these SMA connectors. I see these little tiny, they're called U.FL connectors. So for like less than $1 each, you can get a cable that snaps onto that connector, then snaps onto this connector. This is my amplifier board. And again, this amplifier board is frequency agnostic, but it puts out about a 1-watt square wave into 50 ohms. I'm using basically logic line drivers or bus buffers to generate a differential signal into this transformer and a 2-to-1 step up. It gives me a nice clean, square wave 1-watt out. And then let's see, also I ended up developing a 6-channel current limiter, because these things, if you short out the output or even drive them into too low of a load, they just start drawing current. They've got the output impedance it's more like an audio amplifier. Output impedance is really low on these. It's designed to drive a 50 ohm load, but the output impedance is, I don't know, closer to 10 ohms maybe. So if you put a low impedance load on it, these are probably going to overheat. So 6-channel foldback current limiter, designed that, and that feeds run 5 volts into this, and these are designed to run on 5 volts, but they've got some degree of protection from the current with the current limiter. Yes.
So are there 6 of these amps in the beacon blaster set?
Yes, 6 of these. And let's see if I don't know if I got a picture here. Oh, well, here's the innards of the beacon blaster. This is that controller board I was showing you. Here are the amplifiers. Here's my current limiter and regulator. Put 12 volts in. Puts out 5 volts, which feeds the controller board. The controller board can also be powered just by the USB. It's for configuration, you don't need to power up the amplifiers, but the amplifiers require the 12 volts regulated down to 5, and then current limited. And then these outputs go out. I don't know, do I have a picture of yeah, here we go. This is the beacon blaster. We can thank Steve Roberts for printing out this nice label on his amazing printer. And here are the 6 outputs: the GPS antenna in, the aux splitter output, the 10 megahertz reference, a little blinky light there, a power switch, USB, and 12 volts. Okay, so now we've got 6 square waves coming out. You can't connect, you shouldn't connect those to an antenna. You really ought to filter them, and we're going for spurious, better than 40 dB down. That's kind of the US limit. And
So you would be if you did do that, you would be transmitting a fair amount of harmonics, right?
Yeah, you'd be transmitting a lot of harmonics. So you need a filter, and you probably don't want to run 6 antennas. A lot of us, myself included, are using this end-fed antenna. My 80 meters, and up in frequency. It's got a transformer in a box, and then just a long wire. It's got a little loading coil, not too far to kind of make it work better on harmonics on the higher frequencies, I believe. Or low. Anyway, they tune the antenna. It works pretty well for all of the bands we're talking about. SWRs, 2 to 1, or mostly like 1.5 to 1. I think it's as bad as 2 to 1. And surprisingly enough, the SWR is actually pretty bad if you're in between bands, which tells me they just don't have a big resistor dummy load inside the box of the, along with the matching transformer. But it actually must be at least somewhat efficient, because off frequency, the SWR goes up. That tells you there's not a lot of loss. Anyway, so a single antenna, how are we going to feed a single antenna from these 6 outputs? So ended up developing a combiner. This is a 4-channel combiner. It was easy, the first one I did, and designed it using surface mount inductors and surface mount capacitors. And this circuit here is a low-pass filter, basically one section, another section, and then this capacitor provides the coupling. So I'll show you related frequency response. But this capacitor then goes through a series inductor. So this is its own series resonant circuit. And I have these tuned so that it provides a good coupling between at the fundamental, but it also provides a notch at the third harmonic. Being a square wave coming out here, the third harmonic is the big problem. So I suck out the third harmonic with that and get a pretty good output. Also, the advantage of this filter design is that it's high impedance off the frequency of interest because of the series resonant circuit, which means I can connect multiples of these together in parallel. This is the antenna connection common here, and in this case, I got 4 of these things all tuned to different frequencies connected at a common point, which then goes to the antenna. The 1 watt square wave goes in here, goes through the filter, and then comes out here. But they really don't interact that much. If I'd used a different type of low-pass filter, like a traditional pi network with capacitors to ground, that goes low impedance away from the center frequency, and you'd end up with horrible suckouts. But this topology works really well if you're trying to combine them. So this lets us, in this case, have 4 channels feeding 1 antenna. But hey, that's only 4 channels. So here I go. I made a 7-band combiner, and we got a number of these out in the field now. In order to doing it, it's got a similar topology, actually almost identical topology to that 4-band with the surface mount, but I had to stick some more frequencies in between the 4 bands. The 4 bands I was using were 1 octave apart, so it's pretty easy to keep the filters from interacting. But getting them closer together means I needed higher Q, and the whole Q bandwidth loss thing is a trade-off. And the surface mount inductors just couldn't cut it. I ended up losing too much power if I tried to go with surface mount inductor. So went with hand-wound toroids. And this works really well, but it's stupidly expensive, because if I had to pay for these, they'd be like $10 each in reasonable quantities and $5 each in stupidly large quantities. So I end up hand winding them. It takes me about 5 minutes to wind each of them. And so I pay myself, $2.75 an hour to make these things, because nobody's going to want to pay what they're actually worth. At least that's what I tell myself. Here is the response of these. Turns out I didn't use that series resonant coupling for suck out. It's just a capacitor to ground in between the sections, because the Q of these filters is high enough. You can see here, third harmonic's already attenuated pretty well, so I didn't need that extra notch in the response. So 7-band combiner. These are the 4-band and the 7-band. I'm selling them on the website. So now I compromise. Here's a 6-band combiner using surface mount. I've got 2 of these in operation, one here in Occidental, one in Friday Harbor. And yeah, lose a little bit, maybe a dB worse loss, but works, you know, what's a dB among friends? And it's actually kind of affordable. And this, so I got 7 channels here, 6 channels here, which nicely matches the Beacon Blaster 6. This port here, I just stuck a 40 dB attenuator. That says 30 dB, but I changed my mind. It's now 40 dB attenuator. So I've got a monitor port. I can connect that up to a spectrum analyzer or something if I want to see what's going on. And so that's going to be available if somebody wants, you know, somebody needs it. Where else? Another thing we needed. So the thing about Turn Island Systems is these are things that either Steve or I need, or somebody else tells me that they need. I'm kind of not really going out and saying I've got this brilliant idea and I've got to sell it to the world. It's more like people come to me and say, "Hey, I've got this problem. Can you help solve it?" So that's how we're coming up with these things. And you know, it has to be anyway. So this is a clock distribution buffer. Got 10 megahertz reference coming out of the Bodnar, let's say, but if you've got multiple receivers, a lot of the people I'm associated with, they've got multiple SDR receiver banks or multiple transmitters. Because they don't have a Beacon Blaster 6, they've got other single band transmitters, and they need a reference for those. Maybe you got a bunch of QDXs. So we got one 10 megahertz clock coming out of the GPSDO, and you want to distribute it. This thing has 1 input, 5 outputs, and you can buy distribution buffers. I've got one. It's an old video buffer that I bought surplus, and it's a rack mounted unit, and other people make these, but I decided, what the hey, I've got a nice little metal box here and easy enough. Doesn't require any software like that, so I decided I'd make that. And so I've got a few of these in use. I'm using most of them myself. Okay, getting near the end here. Okay, a lot of these people are using SDRs, SDR receivers, and turns out the front end filter on a lot of them maybe isn't as good as it should be. Depends on what sample rate. Sometimes they'll dial down the sample rate, and so just for power thermal issues, bandwidth on the USB cable, they just don't need that much because they're not going past 30 megahertz at the antenna port. But the anti-aliasing filter wasn't designed for that inside the SDR, or maybe it had a crappy anti-aliasing filter to start with. So, and the other thing with SDRs is you connect it to a broadband antenna, and most of the people I'm working with, they've got broadband. They are picking up the entire HF band from 0 to 30 hertz. During this Eclipse, some of them were recording, including Phil Karn, recording the entire bandwidth. I forget, I wrote about this somewhere, but using like a 2.7 terabyte, I don't know, a multi-terabyte drive, they can record like 6 hours continuous full bandwidth, 0 to 30 megahertz. For later analysis. Then they can take the output of that and feed it to whatever analysis tools they want. This is the full spectrum, but that full spectrum includes FM well, it includes AM radio, it includes other lower frequency stuff, and you really don't need sensitivity at the lower frequencies, because, as we all know, because the atmospheric noise is too high anyway. The noise floor, natural noise floor. So it's often a good idea to attenuate the lower frequencies to just to help get rid of overload from AM broadcast, and certainly attenuate the higher frequencies like FM broadcast or police band radios and stuff like that. So I was asked to design a filter like this. It's a shelf filter. Okay, you notice, and it's got switchable 2 shelf filter sections. The shelf filter starts out, in this case, with both sections switched in, it's 20 dB down at 1 megahertz, and then it gradually it rises up. The center point's about 10 megahertz, and then it finally comes to kind of minimum attenuation up to 28 or 30 megahertz. So this green line here is with the shelf filter, and then you can swap these jumpers, move these jumpers over and take out the filters. And here is the low pass, just anti-aliasing filter. So it starts out flat, and then at 28 megahertz, it starts rolling off. And there are 4 sections here. It's an elliptic design or Cower filter, depending on the same thing. So you got notches which help your transition band here, make it sharper. So this thing apparently works really, really well to, if you stick it on the input to your SDR, it really helps avoid overload and aliasing. So selling these, this is probably sold more of these, and these things are pretty cheap. You can go onto the Turn Island System website and take a look. I'm doing this for fun. I'm not doing it for profit, but I'm trying not to at least lose money with every one I sell. I don't mind investing money up front. My time is free, but I don't want to lose money when I ship something out. So I make enough for postage and maybe a little bit extra. Well, more than a little bit, but anyway, it's still a reasonable price. You can take a look. So let's see, anything else? No, okay. And now we come to links. TurnIslandSystems.com, my blog, where I sometimes put other technical stuff, WB6DXE, Steve's, microchip.com. The guys that are doing the Whisper Demon and doing a lot of the stuff during the Eclipse and just general propagation research, check that out, whisperdemon.org. And then HamSci, which is an amateur radio science. It's run by University of Scranton, I think. And they're really involved with propagation research and the recent eclipse and the upcoming eclipse. Next year, we've got another total eclipse. This was just, I think, annular. So these are cool sites to check out. And I guess that's about it for Turn Island Systems. Oh, yeah. Beacon Blaster 6, it's cool, but there are too many pieces to it. I have to assemble all these little boards, and that made sense for the first wait, stop share, here we go, sorry. That made sense for this. We're figuring out what it needed to do, and arguing about the functions, what went where and what we had to make flexible, what we were pretty comfortable with that could be fixed. So now that we know, I'm going to do a Beacon Blaster 8. And I don't know if anyone's going to need it, but if it's going to be easier to build, probably cheaper to build, certainly cheaper if somebody had to be paid for their assembly time. And it'll actually have better performance because I'm going to be able to improve the way I'm modulating. So I expect the spurs will be even better. And it'll look prettier. It'll be a slightly smaller box, won't require a rack, won't be rack mounted size. So that's coming up. It's in process. I don't have a schedule for it, but I hope I'll have some available in time for next year's Eclipse. So there you go, Turn Island Systems. Any questions, fire away. I love to talk, as you can tell, about any of this.
Paul, who makes your PCBs? Where do you send those off?
I take those, I get them from JLC PCB.
Yeah.
And actually, most of these, many of these anyway, I'm having assembled at JLC. That main board, the main beacon blaster board, that is all assembled at JLC. The board with the toroids, that filter, I'm having them assemble it with capacitors. The toroids are through-hole parts, so I wind those, solder those in, and I solder the SMA connectors on at that point. And then I test everything before I ship it out. But most of the other smaller boxes, I've only made a few of the frequency counters or the clock boxes, and I've actually got a small surface mount pick and place machine in my garage. And it's kind of fun, but I'd rather have somebody else build it even with that. But I do use that, or I did not lately, but I will. And you can get a stainless steel solder paste stencil from JLC. It's just ludicrously cheap from JLC. I mean, the shipping is often as much as the boards, and even with that, it's a bargain if you value your time and sanity at all.
And they're quick. They're
Yeah,
unbelievably quick.
yeah. I mean, and I've ordered some, using the slow boat, the absolute slowest method to save a few bucks, and takes longer, but I as you may know, I kind of move around a lot. So sometimes if I'm in one location, I'll order something and have it shipped up to where I'm going to be. So I might take a slower path on that and save a couple bucks. But even the normal shipping, DHL that they use, it's still way better than doing it yourself. So I'm very happy with them. Anything else?
Oh yeah. Okay. So the Beacon Blaster 6 is the advantage of having the 6 bands in one box, that they're all off of the same clock. Is there a scientific?
There would be no reason you couldn't have 6 independent transmitters as long as they were all locked to a good frequency reference. Depending on some people are, during the Eclipse, one guy in particular was he actually used the motherboard for the Beacon Blaster 6 to provide him with one FSK output on around 50 megahertz, and then he mixed that up using analog mixer techniques in his own design to multiple outputs, and those then are now kind of phase aligned, if you will. And he also had another signal that he was putting out, carrier provided by one of the Beacon Blaster ports. It's all programmable with the Beacon Blaster. It's this configuration file. You can make any port sing and dance any way you want. And he was using the WWV-based pulse per second to invert the phase on this carrier, which was adjacent to the whisper bands, once a second. So he is using that as essentially a timestamp. And then these receivers that are picking up either a single band or the full spectrum, you can then tease out this phase reversal signal to give you timing. And if you got 2 receivers and you got them on 2 different antenna polarizations, some people are doing that, you're going to have different delay paths perhaps through that with the 2 receivers. But you can, in post-processing, if you pick up this phase reverse time sync signal, you can then kind of dial out any delays between channels and get them so they're perfectly aligned. I'm getting off topic, but that's the kind of stuff where you need alignment. But with this normal Whisper FSTW4, the signals don't need to be perfectly time aligned. They just need to be reasonably, within 10, 20, 100 milliseconds of each other. And you'll get the information that the Whisper or FST4W decoders are looking for. What they're looking for, absolute frequency, and you can look at Doppler shift there, but they're also looking at what's called spread. This is not the same thing as spread spectrum, which confused me for a while, but it's more of a multipath different Doppler shifts on different multipath paths. Usually, the ionosphere is not like a hard surface mirror. It's kind of squishy, and you can have, certainly different paths, and they each have their own characteristics. So you can characterize what's going on by looking at, you transmit on one frequency. Here's my spectrum analyzer spike on one frequency, but when it comes back, you get these two signals, and they're close together, but they're not exactly right. And this FST4W software will decode up to, I think the resolution is 5 millihertz. And so with that, you can characterize the propagation paths really with some really interesting data. So you need a stabilized transmitter, but you don't need 6 of them in the same box. It's convenient. No point in duplicating a bunch of stuff. The Beacon Blaster 6 is cheaper than 6 of the typical whispered, even dedicated small box whisper transmitters, especially if you got to put an amplifier on. Most of those will put out, I don't know, 10 milliwatts or something like that. So they have to throw an external amplifier, which are cheap, but a matter of convenience. You can haul this thing. One of the Beacon Blasters is on a boat to Antarctica right now. I hope it's on the boat, and they're going to be setting it up. So having something kind of plug and play, and that's the way these were deployed. They're taken out to remote sites, plugged in, pre-configured, and then taken out, plugged in, and apparently they all worked. All I got back was good news, so I was happy to hear that.
One of the things that has fascinated me about your designs, Paul, is that I had no concept that you could use digital components as RF transmitters, and the fact that there's not an RF component other than the passives on your 1 watt amplifier. That was pretty cool.
Yeah. Hey, question I see. The Antarctica station. Go to turnislandsystems.com. The first thing that pops up is kind of the blog page, and I think the most recent blog post, I think, was me apologizing for a bug in the configuration code help file. But the next one down talks about where the Beacon Blaster is going into Antarctica and gives you some background information on it. About the use of basically digital logic to drive create an RF signal. I'm not the first one to do that. I've seen single-ended drivers using bus driver ICs, or you could use a hex inverter if you wanted. Just tie all the outputs together. And these days they're fast enough, and within a chip they're matched well enough that you don't get a lot of I forget the term. Anyway, signal doesn't flow through the output stages very, it works pretty well. What I did was I got tired of burning up little transistors with like a Class E output, because I've gotten 1 watt output using a Class E output stage and using a little SOT23 transistor, tiny little thing, because the things are like 95% efficient. So, if you do the Class E right, so the transistor, it doesn't get that hot unless you do something stupid like drive it with a DC on the gate. You turn it on constantly, and then just the thing pops in a matter of milliseconds. So what I did, go into the differential driver. I guess you could have used a capacitive driver, but I ended up with a differential driver and capacitor coupled. But the way it is, the kind of default state, if the input's high or if the input's low, you don't have a short circuit path through it. Well, that's because of the coupling capacitors. But so the thing is pretty bulletproof as far as the input conditions are concerned. The output, you can overload it. So that's why I had to do the current limiters.
So two last questions. It's fascinating that you've created an amateur radio company, you know, of one or one and a half. Steve, whenever I've talked to Steve, he poo-poos his
Yeah,
participation.
I wouldn't have done this without Steve, and he, at the very least, he provides moral support, but he provides more than that. I mean, we discuss this stuff, but yeah, most of the scut work is me. I will admit to that.
And the last item is, I find it fascinating that there's two amateur radio manufacturers in
Yeah.
Friday Harbor, you know, with Northwest Digital Radio. You guys
Yeah,
get together over here and compare notes?
Well, I've borrowed some of their test equipment sometimes. We sometimes will talk about it because we've got the San Juan, you know, our own local ham club. So one of these days I got to talk them into building this stuff for me, but that hasn't happened yet. But yeah, you know, I mean, Turn On the Systems. I mean, it's technically a company. I mean, we're registered, you know, it's with the state and all that. But I don't think it's going to provide for me in my old age by any means. But we'll see. You know, maybe something will take off, and I'll learn how to actually, how do I work this thing? You know, we'll see. It could happen, and if it does, that's great. If not, you know, keeps me out of the bars. You know, keeps me off the streets, so that's good too. And it means I get to work with and talk with a whole bunch of really smart people, which I really like. I mean, hell, I don't know if anybody's still out there listening, but you know, I've got no engineering degree. I mean, I've got no degree at all. Lucky I survived high school. Started out as a technician. Yeah, I could get I got all the coursework for a AA in electronics technology, but I never bothered to apply for it. So I really learned from other people and on the job, and you know, studying myself. You know, talk to my wife, and you know, she'll tell you how consumed I am by this. When I find something's interesting, I just dive into it, and so I worked my way up, and you know, I got some pretty serious titles out of it. And you know, helped start a company, which is why I can do this now, because it was a successful company. Got bought out, and pretty amazing. But I still haven't kicked the habit. I just love doing this.
I can understand with that background that you just explained. I understand why you and Steve get along so well.
Yeah, no, we're
very similar eclectic career paths.
Yeah, no, we both get a sneer at the people with degrees. You know, yeah, right. No, that's it. I love people with degrees, people who know some of the details. I'm really a generalist. I have areas of synchronization and, you know, spectral stability. You know, I know a bit more than most general engineers. But I do reply in previous companies. You know, I've replied on the skills of you know, other engineers, or when I was, you know, director of engineering. You know, I made sure we assembled a team that knew what the hell they were doing, so they could keep me from doing something extra stupid.
Well, thanks for taking the time to explain this to us. It just fascinates me that, you know, that such a product that's obviously been accepted into the scientific community or the amateur radio scientific community.
Yeah, we're waiting for the scientific community. There's a budget. National Science Foundation is funding a lot of stuff, that this type of ionospheric propagation research. The HAMSci organization has tapped into that, and we'll see. You know, they may end up being interested in what we're doing here. They actually should be, but we'll see. And I have to be careful. Be careful what I ask for, because you know, I might find myself overwhelmed here. I guess that would be a good problem, but one that'll take some effort.
Not only did they get the National Science Foundation grant, but Tapper, on behalf of them, got a grant to design a brand new software-defined radio
The Tangerine, yeah. Yeah, it sounds like
For-
they're
for
making
their-
they're making progress on that.
And now that they can get
Probably
parts
better
again.
than the Kiwi as far as progress is concerned.
Yep.
We'll find out. Yeah, the Tangerine is that we talked about the 888 SDR.
Well, that you and I did, that
Yeah.
hasn't been.
Anyway, a lot of cool SDRs, and they're in a lot of ways they're getting simpler and simpler,
Mhm.
because of the capabilities of the high-speed USB interconnects and the software. Hey, by the way, I don't know. One of the things that filter, that shelf, anti-aliasing filter. One of the things I'm most proud of that is I got a nice endorsement from Phil Karn. He says, this filter really works with my SDR. So Phil Karn, he's one of my heroes. So that was cool.
My hand and I. So, well, thanks, Paul.
Yeah.
Appreciate it.
Boy,
Hang out. Check in any third Tuesday with us.
okay. Yeah, I'll try not to talk so much next time. Thanks.
Oh, it's okay. Anybody have any more questions for Paul? Okay. So this is my monthly quick hit on some interesting stuff that I've seen in Zero and written about in Zero Retries, my newsletter. Multi-mode digital voice modem has been around for quite a while, and it is a mostly software-defined modem that can be programmed variously for the digital voice modes like D-Star, DMR, System Fusion, even FM, and it had a piddling 1200 bits per second AX25 mode. And I had not realized that it could also do paging. The author, Jonathan Naylor, G4KLX, was hired from a grant by ARDC to do more work. There's apparently MMDVM was a typical volunteer project, and there were lots of there be dragons there kind of places in the code that didn't work so well. So having 5 years of experience with MMDVM out in the real world, he knew where there were issues, but he just didn't want to put the time into it as a volunteer again, especially when people were making reasonable amounts of money on selling hardware with the free software. So anyway, Jonathan is now basically hired to fix all of the MMDVM glitches and improve it considerably. And he's adding a data mode now, which I thought was just really cool. So he's basically taking the modulation, the type of modulation that DMR and System Fusion use, the data modulation, and then he's cramming a 9600 bits per second data mode into it. And the best part, in my opinion, he's using a forward error correction system that was designed for data, not voice, that's called IL2P, Improved Layer 2 Protocol. And it's forward error correction. So the data going out is robust, just like digital voice is. And you can put an MMDVM in the middle of a repeater and tell the repeater, okay, right now we want to be doing Yaesu System Fusion or DMR or D-Star or this new data mode now. So for example, you could switch a repeater on to the data mode over in the evening and then do flood distributions of data stuff. And this can be, bog standard repeater. And best of all, you can coordinate it because you can just claim it's an FM repeater. And he's going to be able to, he's certain that he's going to be able to do 19200 bits per second. And he's cautiously optimistic that he can do even 38400 bits per second. But that will probably require a wider channel. So I've been following this, and I've written 3 stories on this now, and it's just awesome. And he's going to do a presentation at PacificCon in San Ramon, California this weekend. which I was hoping to go to, but my wife had some health changes, and we have to work on that. Let's see, where am I? Okay, next. SatNOGS. SatNOGS is Satellite Network Open Source Ground Station, and this is a mature project that a SatNOGS station build from something as simple as a software-defined receiver dongle, a Raspberry Pi, and even a ground plane antenna for 440. And these cubes, there are dozens, if not hundreds, of CubeSats in orbit that a college or even a high school will launch. And it's always, the whole point of a satellite, research satellite, is to get data back from it. And they always set up a ground station at their school, but typically a CubeSat only passes over it for a few minutes a day. So the idea was to distribute a network of ground stations, and this is very heavily done in Europe. There's a lot of these SatNOG stations in Europe, but not so many in the US, especially in the Western US. And they did a press release about having received 8 million telemetry records just a few weeks ago. And I looked it up, and the nearest one to us is on Vancouver Island, and it's not active. And the next closest one is in Portland. So the whole, northwest corner is ripe for needing more SatNOG station. And again, this is a recipe. It's got the image that you flash onto an SD card, and you plug it in with a software-defined radio receiver dongle, and it just works. And then you upload the system tunes, it says, okay, I want to help out however I can. And the system knows where you are. The system knows what the orbital paths are. So it tunes the radio, it listens, it receives, it caches the data that it gets, and then it shoves it off to the mothership.
Dave?
And what's cool is, go ahead.
Yeah, no, just curious. What frequencies are these things operating at? Low VHF?
Typically VHF, the amateur VHF and amateur UHF band, two meters and 440.
Okay.
It's the amateur radio is the lowest hanging fruit. So they typically put some kind of amateur radio payload to justify use of amateur radio spectrum. So like there's one that's going up, that's up there right now is about to be launched, and it's going to be a 9600 bits per second digipeater. These are cheap to build, or they can be complex. You don't have to use an SDR dongle receiver. That's just the cheapest way to get started. You can turn on your high-end, ICOM radio or whatever to receive these things. And again, this is like, you can do this while you're not using your station. And it's receive only. There's no transmitting. So anybody can do this. And in fact, a lot of people that are not hams do this. Anyway, I thought this was really cool. And what twigged this has been around for a while, but what twigged it was that they've just completed 8 million downloads, which I thought was just quite the accomplishment. And considering that these, most of these reception reports would otherwise just have completely been lost, because the satellite transmits continuously all over the world. But, the only time the data is actually receivable is when they're over their home college or something. This was a cool PC that I didn't even know I was looking for. There's times when you just want to use a PC for Windows, various things in the shack. And this one kind of came out of nowhere. And I didn't realize, this had the magic combination that I'd been looking for in the background. It's low profile. There's no fan. It's the heat sink is the case, basically. 8 USB ports, native USB ports, no extenders needed. 12-volt input and under $300. And it's got standard interfaces for RAM and solid state drive. So that I believe that one's in my future. AREDN, Amateur Radio Emergency Digital Network. This is the folks who have a firmware load for microwave equipment. They've been doing an awful lot of work this year. They just switched to, I can't remember the name of the framework, but they basically, all of the graphical user interface was taking up a lot of system resources, and they switched to a much more efficient one. And that freed up enough RAM that they could even put the tunnel server or tunnel client, I guess, and tunnel server into every distribution. It used to be optional. They've done a lot of UI and network tweaks. This is a new one that was cool. So if you've ever used AREDN, and you've used the tunneling, you know that the node list can get really big and it slows down network updates. So they created this thing called super nodes that if you really want to see what's going on, you can go into the super node, and the super node is a bigger, beefier piece of equipment. And it will if you want to connect to somebody that's connected via a super node, it'll just work. It's basically a tunneling system within a tunneling system. They now support, there was a patent, or I don't remember, intellectual property issue with trying to do open source development on 802.11 AC hardware that expired earlier this year. That means that they could then port AREDN software to take advantage of the more capable 802.11 AC, which basically meant faster data over the air because you could have bigger channels and you could aggregate channels. And they're phasing out support for older devices. So you want to get the biggest RAM you can to provide you with some investment protection. And then there's Zero Retries, which publishes every Friday. And it's been going for 2 years now, or 2.5 years now, and it's within spitting distance of 1,000 subscribers. So I'm tickled about that. And okay, that was my quick, oh, there's a chat. Yes, the ground station does correct for Doppler shift. And especially if you have this software can run on just about anything. So, it tunes it the same way that, you would manually tune it. As it passes overhead and you start to hear it, you adjust the frequency slightly. So, they can do that easily in the software-defined radio framework. And Rob, if you didn't get the answer online, the station in Antarctica is the German station. So, okay. So, any other questions for the good of our stuff?
Yeah, I had a question about AREDN.
Sure.
I noticed that there's very few stations in this area. It seems to have died off. Hardly anybody's actually using it. And I noticed that most of the stations that are listed on the map haven't updated their firmware in like 3 years. I'm one of the few. And I have probably 5 or 6 different AREDN devices. I've got 2 more coming in here in about a day for my go kit. But can you hear me? I have the mic off here because I don't want feedback.
Your audio is just a little bit low, Rob, but we do hear you.
Okay. So, anyways, I just wanted to encourage others because I'd really like to get into AREDN for our area. And now with the supernode stuff, I'd like to actually make a couple tunnels, one down to Arizona, set up a node down there in Yuma when I get down there, and have another tunnel maybe going to LA. But now with the supernode stuff, I can actually turn that on without it flooding our whole network and theirs with all our stuff. So now you can actually separate that, which is great. And I just wanted to encourage others that have the equipment or that would like to get interested up here in our area to either upgrade their stuff with the current software, because the new I forgot which language that they're using now for the GUI, but it's a lot more responsive as well. It's slimmer, a lot less memory intensive, which is awesome. And it works pretty good. And they're fixing bugs like constantly. So
I think you and I ought to get together about this and kind of lead the charge, because I feel the same way. We're going to lose a key node at the search and rescue building, by the end of this year. Well, I guess cutoff date is May, but they're not going to do anything with it. And of course, it's really hard to do with, because it's microwave. And another thing was that AREDN is really de-emphasizing any use of 2.4 gigahertz. All of the activity and all of the hardware is basically going into the 5 gig MikroTik equipment. One of the things we could be doing is we could theoretically have a node up on Lookout, but we do have a perfectly good microwave network here in Whatcom County, which is ham-WAN. And they already staked out Lookout Mountain. So we ought to get it's perfectly reasonable to have AREDN as a subnet of a ham-WAN connection. So that's what I'll be doing. I've had ham-WAN equipment for forever, and I just never gotten it on the air, and I really got to get going on that. And then I could basically take care of my neighborhood with AREDN. So you and I, since we're the most interested ones at the moment, we ought to maybe.
I didn't realize that they were phasing out the 2.4, which
they just start putting a lot of work into the units that are 2.4.
Okay. So
now if there's
almost all my stuff is 2.4, right?
Yeah, well, me too. 2.4 makes, but they're a bit blinded by the fact that they're based in Southern California. So, they basically said 2.4, we basically only have 1 or 2 good channels, and there's so much more capacity on 5 gig. So that's where they're putting all their work. So yeah, let's
when I get back from Arizona, I'd like to get back to go to Hugh and Bud if he's still interested in AREDN, and a few other people, whoever's interested, and maybe set something like that out. I'm in a really bad location for doing anything like that, but I do have some other people in our neighborhood that newer hams that might be able to.
If it's your station and it's directly under your control, even though it's not physically at your place, it's totally legal to set it up that way. AREDN just has so much potential. And the other thing is that I make the case whenever I can, whenever I'm writing about it. There's also, in addition to being a wide area network, it makes a fantastic local area network. So in my opinion, you ought to have one of the tiny little AREDN units in every Go kit. And then basically, if you show up in the same facility, like the EOC, we've got our own private wireless LAN that that's just ours, and we don't even have to configure. It just, it links up, and we can then, run PBXs or, all the other, a little bulletin board system, a chat server, all that stuff can be, running locally internally to us, and we don't have to say, Mother, may I check into the EOC's Wi-Fi, or we don't have to have cellular. We don't have to have a system out there in the cloud. All that stuff is locally hosted.
Yeah.
So there, let's see. Okay, one more. Yeah. Oh, Paul's Paul enjoys having an audience.
Oh, I do. It's pretty sad, really.
No, not at all. It's cool. Let's see. Anything else? So I don't want to play the video, especially if Bud hasn't had a chance to sanitize it, because it rambled on for 26 minutes in our conversation. But very
We can
briefly,
save that for a future meeting. It'll be fine.
okay, that's a great idea. That's a great idea. So, okay. Anything else from anyone? I have a quick, sneaky one. Mr. Roberts, we haven't heard much from you, so tell us about you and what you're doing and amateur radio, if any.
I'm not much amateur radio these days. I keep meaning to put up an antenna. Paul's giving me a well-deserved hard time about that.
Yes.
My old tower is still sitting over in Camino, and I've got beams and boxes, and nobody wants to hear about things that I'm not using, including.
I tell Steve all he needs is some wire, and I've got a bunch of extra wire. You don't need tower. You don't need a beam. Just put something in the air. Okay, continue, Steve. I'm sorry.
I just sold a wave node on eBay today. You know, those SWR monitors that uses the external sensor, so you're not pulling coax down into your shack. It's been sitting around for about 10 years. So anyway, all my effort these days has been going into the lab and getting this thing all built and ready to use. And I'm cranking. Gosh, I can't keep up. And I need an employee and wondering what the heck I'm doing at age 71. Just coming in every day and burning through film and video and things. But it is fun. It's weirdly addictive. But nothing fun these days. There's the electronics lab is in the other trailer next to this, and it's become kind of a storage area at the moment. So wish I had more fun news, but a strong nibble in the boat. So that's exciting.
Good.
So.
The
Oh, you know about the microchip, right? So Steve, do you know about the microchip? It's got a new home.
Right.
Yes.
So you were referring to data weight.
Yes. Yeah.
Nibble on data weight.
Yeah, I'm never getting data weight off the dock. It's too much. So I've got a really nice, strong, interesting nibble. I posted about it a couple of days ago, and good answers. So we'll see. Fingers crossed. But the guy who's doing the microchip has been doing it completely in the spirit of the project. I mean, geeking it out, doing, he's already put in the network, and he did a lot of.
I don't know why a kayak needs a local area network, but go ahead.
It's a geeky boat.
Yeah. Okay.
The best part with him is that he wants to do pretty much what I was planning on doing. Missouri River, starting in Montana, and Great Loop, and in pieces over time. But he's going to be doing a lot of his test sails down in Lake Sammamish. He's actually using it and doing things. So instead of being a really bad shelf, as it has for the last 15 or 20 years, it's now getting loved. So I'm happy.
Great.
So.
Well, is that info for public consumption? Is he publicity seeking as you were in the thick of it?
I don't know on the same level, but he's not being shy, and it's okay to mention his name. I can send you a link. So I don't know how much he's done with his site yet. His name's Ivan Judson. He's down in Seattle, and Microsoft, ex-MIT Media Lab, ex-Argonne National Labs. I met him at MIT, and then for the last decade or so, he's been doing something at Microsoft, but I'm not sure.
Cool. Okay. Yes, I would very much like to be put in touch with him.
Good. I'll do it. He's not a ham, though. We need to fix that.
What?
He's not a ham.
Oh,
we need to fix that.
Once he discovers how easy it is to do things, on radio with a ham license, ask for forgiveness rather than permission.
That's right. It needs some proper telemetry, and that's what he's interested in now. He's got the mechanicals kind of sorted, so that's one test sales.
Okay. Cool. Okay. We're going to wind her down here in plenty of time to be out of the facility here by 2100. So
Hey,
Anybody else?
Yeah, speaking of new hams, I just want to shout out to my son-in-law. Got interested in ham radio. He got his technician license about a month ago, and then 2 weeks after that, he got his general class license. So we're setting him up. So it's not just old geezers. So it's good. I was really thrilled to see him show an interest in that because you it's nice to have some new blood.
It's been, as far as I'm concerned, horribly underreported, but every DEF CON has a ham radio class and a ham radio licensing session. Some are, more successful. Some years it's more successful than others. But I am seeing a very steady influx of techies into amateur radio and it's one of the reasons I started Zero Retries, because once they discovered that you can do interesting to them things in amateur radio, like AREDN, microwave networking, software-defined radio, where you buy a box and your experimentation is mostly in the software realm. The word is finally getting out about amateur radio through the unconventional channels, because as much as I would love to cheerlead the ARRL, they are just missing in action for so much of this. These communities, the maker community, the software-defined radio community, new radio. I mean, the most prominent place you could possibly want to be in radio technology in the 2020s is the GNU Radio Conference, and ARRL just is a no-show. It's just heartbreaking. But there was amateur radio there. There were several sessions, including my buddy Dennis Rosenauer, who did a bang-up presentation about how he modeled his system well in advance, his EME system well in advance, and the hardware came in within a few dB of exactly how he predicted it would. So he's gonna, and he built all of his own hardware. He's a RF design engineer. So there's a lot of those stories out there. So anyway, so we're gonna close her down and say 7-3 to all the online participants. And
Good seeing you.
And Steve,
Paul, you and Paul, Steve, please stop in. We're here every third Tuesday.
Yeah,
and we talk.
And Steve Stroh, again, thank you for inviting me. As you can tell, I love talking, not just turn on systems, but technology, just the whole process in general. I mean, that's, I mean, I tell people, and I sincerely believe it, yeah, my job was engineering, but at the fundamental core, I am an engineer. I always will be. I was born an engineer, and I didn't know it, for a few years.
It's a mindset. It's not necessary.
Yeah. So, just the opportunity to, interact with other people who kind of share, just my enthusiasm, because I'm incredibly enthusiastic about all of this. It's just so amazing.
You would have to be to be cranking out the stuff you're cranking out.
Oh, that's the fun part, man. I just, that actual, I wish I could get somebody, I don't mind getting my hands dirty. I can show you fresh soldering iron burns and all that, and that's cool. But just the whole conceptual process, the first 20% of a project, figuring out what it is you need to do, and then figuring out how you're going to figure out how to do it. And then, just, again, fascinating. And it's stuff that I just can't imagine not having. And ham radio has been a big part of that all my life. I've not been an active ham. I mean, I haven't, I picked up the microphone to actually talk to somebody once in the last 2 or 3 years. And that was to try to make a contact with my son-in-law, from Friday Harbor to Petaluma, which is where he lives. And we did barely. But just the fact that ham radio lets me do this type of design work and interact with people who, you know, appreciate it, who give me ideas, and I've learned a lot, you know, even recently. So anyway, it's wonderful, and I appreciate what you're doing, Steve, and you know, again, thanks for inviting me, because it's just a whole lot of fun.
Thank you, Paul.
Oh, again, my
7 for
pleasure.
y'all.
Thank you guys.
Okay, and Bud, how am I going to find this if I wanted to subject myself to watching myself again or everything?
Well,
How would I find it?
I'll send you a link to the email. The link will go out to all of our members.
Okay.
But so the best thing to do would be to join our digital group IO. Go to MBARC.com or .org, isn't it? And you'll find the links there to the digital group and join us. But I'll find your email address.
Send me a link or spell it out.
MBARC.
Mount Baker Amateur Radio Club, MBARC.
MBARC.org.
Okay, I actually wrote that down. I'll take a look at that. But send me the link anyway.
Yeah, I will.
Thank you. Thank you.
I'll hunt up your email address. That shouldn't be too hard.
Yeah, I'm Paul at wb6cxc.com always works, and there
There
are
you go.
others. I got plenty of them.
All right.
Okay. Thanks, everybody.
Okay.